Okay, hello everyone. Let's go back to the technology of the IPv6 transition. And for our network, we will change the IPv4 network to the IPv6 network due to the limitation of the IPv4 address. But it will spend a long time for us to change the v4 to the v6 because most of our application is based on the v4 network. So during the developing time, we need some transition technology to spend time for. Sometimes you only have the v4 network, but you have some v6 servers need to be provided for, need to be supplied for the internet user. Or sometimes, or in the late time, you have still established the v6 network, but there still have some exist v4 users need to connect to the v4 services. So for both of these scenarios, we need to use the transition technology to support our transfer for the traffics. So this class we will introduce some kind of transition technology such as the tunnel. First is v6 over v4 tunnel. This tunnel, that means you just use the v4 network. Over the v4 network, you transform the v6 traffic. And for this tunnel, such as the manually tunnel, the automatic tunnel, or the 6PE and 6VPE. And another kind of tunnel is the v4 over v6. This tunnel we will use in the later of the changing time. That means you have still established the v6 network, but you have still some exist v4 applications need to be accessed to for the internet v4 users. So in this scenario, you need to use the v6 network to overlay to transform the v4 traffic. And also for the scenario of the data center, you need to apply the service for the internet user. And in the early time, it's no need for you to change the data center network. You only need to change the v4 address to the v6 address. So in that scenario, we just use the NAT, just for network address translation technology is enough. And for this translation technology, there are two kinds of technology we will introduce in this course. One is the NAT64, another is IVI. Okay, so next we will introduce this kind of transition technology. And before the transition technology, we will do some basic review about the IPv6, such of the address, the classification, and how to plan and assign the IPv6 address in our networks. Okay, so the first part is about the v6 basics. So what's the problem for the v4? That is the INA. The INA shows the last 5 class A IPv4 address segment in the February 2011. I think all of you know this information. So this means it has been more difficult to obtain available v4 address since then. So because the v4 IP address is 22 bits, it's not enough for the expanded of our network, and it's not enough for the expanded of a lot of applications. So in the future, we need to use IPv6, who has the 128 bits length address to deploy our networks. So for the v6 packet, this is v6 packet header. For the header, we some field of the header, they have the same field for the version, for the traffic class used for the queues, and Tailor length, source address, destination address. These are all these are the similar field, and something are new. For example, the flow label, and something are removed for the fragment and for the authentication. So for these two remove parts, you just use the extension header for IPv6 extension header to support all of the other extension functions such as the fragment, the authentication. So this different between the v6 and the v4. And what is the extension header? For the IPv6, it uses the extension header to support extended functions, such as it uses the next header field. It uses the next header field to tell you what is the next part of the function it will support to. And for the next header, for the extend header, it has a hop by hop options header, the destination options header, the routing header, the fragment header. The fragment is just use the IP fragment, just similar to the IPv4, and the authentication header. So authentication is used for the IPv6. So do you remember the OSPF PF version 3? It remove for its packet header. It also remove the authentication field because it can use the IPv6 authentication function just based on the authentication header. And finally, the encapsulating security payload header. And for all of the header, it need obey some rules to send one by one in order. First is the IPv6 basic header, and then is hop by hop, and then destination and routing and fragment and authentication and others. So this is all of the information you can check by our IA.com and core technology. Okay, and how about the IPv6 address? For the IPv6 address, its length is 128 bits, so it's so long. It's enough for us for our expanded network and expanded application. And the format of the IPv6 is use the colon. It's separated by the colon and use the hexadecimal digit, just 0 to 9, A to F, to determine as the address format. And for the IPv6 address is also separated for two parts. The first is network prefix, just like the network ID of the v4 IP address. And another part is the interface ID. And the interface ID just look like the host ID of the v4 IP address. And then it's about the classification of the IPv6 address. It do not have any broadcast address anymore. It has the unicast, anycast, and multicast address. And the most important for us is the unicast address. For the unicast address, it has three kinds of classification, three kinds of types. The first is GUA, just the global unicast address. It's also known as an aggregatable GUA. This type of address is globally unique and is used by hosts that need to access the internet. It's just like the public IPv4 address. And another one is the ULI. It's a unique local address. It's a private IPv6 address that can be used only on the internet. And this type of address cannot be routed on an IPv6 public network, and therefore can be used to directly access public servers. And it's just like the private IPv4 address. And for this kind of network prefix, it suggests FC00 and with a length of 7. And another important unicast address is the link local, and the link local is with the special network prefix, the FE80 with the length of 10. And and it's just another type of v6 address within a limited application scope, and this scope is only the local link. So this is three classification of IPv6 and also three classification of the unicast address. And this part is the service process of IPv6 unicast address. First, you need to do the configuration of the address. For the most important one is the GUA. The GUA you can configure it by yourself, just by the configuration about just by the command of IPv6 address and the detail address. And you can also use the stateful address to configuration. Just based on the DHCP version 6 protocol. And you can also use the stateless address to configuration, just SRAC based on the NDP protocol. And for the LLA, just for the link local address, you can also configure it manually or generated by the system, or dynamically generated based on the EUI 64 standard. After you configure the IPv6 address, you need to detect whether there is another same IPv6 address as me. If there is a same, that means it's a confliction here. So you need to do the DD process to detect the IP address, and then you can put this IP address to the. You can encapsulate the. You need to encapsulate the v6 address, and before that, you need to do the address resolution, such as just like the AIP to get the match between the IP and the MAC address, and then you can do the IPv6 data forwarding, just like the IPv4. And how to configure the GUI? I just mentioned it. You can configure it by yourself. Just configure it manually, or you can generate in EUI 64 format to get the interface ID. To get the interface ID, to get the prefix, and then the interface ID can be manually configured. And the second part is the stateful address. Just based on the DHCP version 6, looks like the DHCP version 4. You can configure it to send the request to get the IPv6 address, and it will advertise. The server will reply you, and will for the server in the network will apply you request, and then you can request for the specific IPv6 address, and then it will reply you the IPv6 address and other parameters such as DNS. And the final one is about the NDT, so the SRAC. You can generate a link local address, and you can use the link local address to send to discover routers who have an IPv6 address, and then you can get the network prefix from the router by the iMessage, and then you can generate a GUI address with the prefix and the interface ID, and then you can just use the created IPv6 unicast address to do the DD process to detect if there is any confliction. And finally, if no, you can just use the IPv6 address to do the configuration, to do the communication of the IPv6. Okay, and for the real network, how can we apply the IPv6 address? There are two methods for us. One is the peer address space, another is PI address space. For the PA is the INNA assign this part of address to the regional internet registry, and for the regional internet registry will assign this part of address to the ISP. That means the ISP can apply a part of IPv6 address from the regional internet register, and for the enterprise or for the users, you can apply the IPv6 address from the ISP, just like the IPv4, and then you can assign this IPv6 address to your own network and to do the configuration. However, if your enterprise is a large-scale enterprise, you can just you can directly apply the IPv6 address from the regional internet registry, because if you apply it directly, that means you have own IPv6 address, and this part of IPv6 address can connect to different ISPs, and you can just deploy the IPv6 address by yourself, just based on your own services, your own applications. So these are two kinds of address. For small and medium-sized enterprise, we suggest you use the PA address just applied from the ISP. And if you are the large one, I hope you can just use the PI address, just apply the IP address from the regional internet registry. And if you have applied the IPv6 address already, and then you need to deploy. You need to do the planning and the deploy of the IPv6 address, and this is the process for you to do the planning. First, you need to analyze the requirement and do the configuration. You need to analyze the requirement, such as how big the network you are, and how many applications you need to support to, and how many departments, how many sites, how many groups, as others, and so on. So you need to analyze the requirement first, and then based on the requirement, you can just design the address structure. For first part, as usual, we will separate the address for three parts. First is the fixed prefix, and the fixed prefix is just determine what is the enterprise you are, and the second part is the user-defined practice and a prefix. And the user-defined practice, you can just plan it based on the department, based on the services, based on the different network. All of them are okay. And the final part is just the host address. And then is the definition of the prefix. Just like that. For the user, you need to define the user-defined prefix. Just this part, you need to think about it. Just based on the region, the province, the city, the country, the office, the department, the service, the applications, and so on. Just to decide the user-defined prefix part, and finally you can just do the configuration to do the assignment of the IPv6 address. So, for example, this is overall IPv6 address planning of bank, and first 32 prefix is the fixed one. For example, if you use a PI address group, it just apply the IPv6 prefix address from the regional internet industry. So it assigns this part of IPv6 address to this bank, and this part is a fixed one. It just matched to this bank, and the next 32 part is the user-defined one. user-defined part, and for this part it is separated separated. The first 8 bits is for the organization, and the second 4 bits is for the level 2 organization, such as the HQ, the branch A, the branch B, the branch C, and so on. And for each level 2 organization, it has different applications. So such as the HQ, it has a lot of applications such as the production, the office, the development and test, and so on. And then is the network zone for the application or the production application, such as this. It has the production terminals, the external DMZ, the eBank web zone, the app zone, and so on. So you can just determine the IPv6 address just one part by one part, just like this. And so because you have a long IPv6 address, so this assignment process is in order. Okay, so for example, for the HQ production service zone, the IP address is, this part is the fixed one, right? 32 lines long is the fixed one, and then this part is for 0000 and 00, and for the product service zone is like this, right? So the value is 4 because the value is 4 here. And the next is HQ production call service zone. HQ production call service zone is here. So the value is 6. So it's here. So you can just assign to the planning and deployment just like this example. Okay, this is all basic about the IPv6. We just do the review about the IPv6 address and IPv6 address classification and how to assign the IPv6 address, because after a long, maybe next week, we will introduce the IPv6 plus and the trend of the development of the IPv6 in different scenario, for the campus scenario, for the barrier 1 network, and for the data center. And for different scenarios, they will for different scenarios terminals, they will have different methods to get the IPv6 address. And for different enterprise networks, they also use different way to apply the IP address. Someone use the PI, someone use the PA. So we need to have have this knowledge before we go to learn this part of knowledge. So we do the review about the IPv6 basics. Okay, and the next part is a key part of this slide is for the IPv6 transition technologies. And for the transition, the background for we use the transition technologies is the IPv4 is exhausted, and the network need to transition to v6, but this requires existing v4 device to be replaced, as these devices are incompatible with v6 networks. The main issue is that replacing a large number of v4 devices will equal huge cost and interrupt services on the left networks. Therefore, the transition from v4 to v6 must be a gradual process, and during the early stage of v4 to v6 transition, there are two stages. During the early stage, from the v4 to the v6, most of the network is IPv4. So you need to consider about how to use the IPv4 network to transform the v6 traffic. And in the late stage of the v4 to the V6 transition, most of the network has been established to V6 network, right? But there is still some existing V4 services. So you need to consider about how to use the V6 network to transfer the V4 traffics. So this is the transition technologies we need to think about. And there are three kinds of transition technologies. The first is IPv4 and IPv6 dual stack. And we have still introduced it on the IPv6 routing, right? That means on the same network, we deploy the V4 we deploy the V4 and V6 together and use the same network to both transform the V4 and V6 service data. So as usual for the dual stack, we will use the IPv4 and V6 routing, such as the OSPF V2 and V3, and ISS for IPv4 and IPv6, and BDP4 and BDP4+. So we will not mention it again in this slide. And the second transition technology is the tunneling technologies, just for establish some tunnels. First kind is about the V6 over V4 tunneling. For this, you just transform the V6 data from the V4 tunnel, overlay the V4 tunnel. And in this kind of tunnels include the manual tunnels, automatic tunnels, and 6PE and 6VPE. And another tunnel is V4 over the V6 tunneling, just like this. Use the V6 tunnel to transform the V4 traffics. And in this part of tunnel, it includes the manual tunnel, the V6 VXLAN tunnels, and SRv6 tunnels. And for the VXLAN and SRv6, for the VXLAN and SRv6, the VXLAN, we will introduce it on the campus. On the campus scenario course, and for the SRv6, we will introduce on the WAN scenario. So these two technology, we will not introduce it again in this slide. We only introduce this kind of tunnel and this part of tunnel. Okay. And final is about the translation technology. And the translation technology normally is used on the data center, just for the DC. And because the data center is the place that supply the service for the internet user to connect to. So in the early time when it supports some V6 applications, it need to connect. For example, in the early time of the data center, when it supports some V6 application, and if the internet V4 users want to connect to it, it needs to do the translation from the V6 address to V4 address, so the V4 internet user can connect to the service. And in the translation technology, there are two normally technology used in the real world. First is the Net64 technology, another is IVI. And for the Huawei, we suggest you use the Net64 technologies because the IVI has some limitation. We will talk about it later. Okay, this is the overview about the transition technology, and next we will introduce it one by one. First is the V6 over V4 tunnel. For the V6 over V4, that means for the tunnel part is just a bare IPv4 network, and we over the V4 network to establish a tunnel, and in this tunnel we use it to transform the V6 traffic. That means we use the tunnel to connect the isolated IPv6 network. Okay, And for the process, how does this tunnel transform the IPv6 traffic is follow as this. The first R1 and R2, these two border devices need to establish the dual stack protocol. That means the dual stack is need to be enabled on the border device just for the R1 and R2. And then you need to configure an IPv6 over IPv4 tunnel. And then when the v6 host want to connect to another v6 host, it will send a normal IPv6 packet to the R1, right? When the R1 receives the IPv6 packet, it will encapsulate into an IPv4 packet by adding a new IPv4 header, and then it becomes an IPv4 packet, so it can be transformed from the tunnel to the next to the end of the tunnel, just to another border device just for the R2. So when the R2 receives this IPv4 package, it will decapsulate this header, and then the packet will become a bare IPv6 packet address, and then it will check the IPv6 routing table and send this packet to the destination. So this is the whole process for the IPv6 over IPv4 tunnels transforming the packet process. And there are two kinds of tunnel. One is manually, another is automatically. And how to difference them is just by how to configure the end of the tunnel. For the source of the tunnel, you must configure it manually. And for the destination of the IPv4 address of the tunnel, you can use two ways to configure it. One is manually, that means you use the manual tunnel. Another is automatically, that means you use the automatic tunnel. For the manual tunnel, you just configure it by yourself. So the first manual IPv6 over IPv4 tunnel, that means you just configure the tunnel's source and destination IPv4 address by yourself. And also for the manual tunnel one, you can also use with the help of the GRE tunnel. You can establish a GRE tunnel to transform the IPv6 header. So you can establish the GRE tunnel, and the IPv6 header is just carried by the GRE, and then you can add a new IPv4 header to become an IPv4 packet and to transform it. And we will not introduce the process again because it's simple. And we will introduce some about the automatic tunnel. The automatic tunnel is for the destination IPv4 address, because for the border one, it needs to change the v6 packet to the v4 packet, right? So for the IPv4 header, you need to contain the source IPv4 address and the destination IPv4 address, right? For the source IPv4 address, you need to configure it by yourself. And for the destination IPv4 address, you can automatically get it. So how to get it? It's just based on some special IPv6 address. That means for these three kind of special tunnels, they contain the IPv4 address into the IPv6 address. So when you receive the IPv6 packet, you can just find the IPv4 address from the destination IPv6 address. So in this way, you can just automatically get the destination IPv4 address. Okay, can you understand it? And there are three kinds of automatic tunnel. The first is automatic IPv4 compatible IPv6 tunnel. And in this tunnel, it has a special IPv6 address. Just like this, the first 96 bits of the address are all 0, and the last 30 bits are an IPv4 address, just the destination address, just the destination IPv4 address of the tunnel. So we can see this example. The 10.1.1.1 is the source IPv4 address of the kernel, and the 10.1.1.2 is the destination IPv4 address kernel. And the special IPv6 address is like this. For the R1, it assigned the kernel 1's IPv6 address like this, with the first 96 bits as 0 and the last 32 bit is the IPv4 address, right? For the 10 is to the hexadecimal is just the A equals to 10, right? So it's 10.0.0.0. So this is the IPv4 address. And for the destination, it also uses this address, IPv6 address. So when the R1 want to communicate with the R2, use the IPv6 address. It will contain the IPv6 source and destination address like this, right? And then it will send this to the kernel. So between it sent to the kernel, it will encapsulate to an IPv4 address. So it will encapsulate the source IPv4 address as 10.1.1.1. It has been configured by yourself manually. And then it will get the destination address from the destination IPv6 address, just here. The A equals to 10, the 01 equals to 1, the 01 equals to 1, the 02 equals to 2. So the destination IPv4 address is 10.1.1.2. And then it will encapsulate it to the destination IPv4 address, and then it become a IPv4 packet, so sent from the kernel. So this is the first one, and for the second one, it's just the different from the first one is it has the different IPv6 format. First, it uses the IPv4 address as the network prefix. First, it has 3-bit FP. The FP indicates the format prefix of aggregatable GOS, and the value is always 0, 0, 1. And then is the TLA. The TLA is indicates the top level aggregator, and the value is 0002. So this just equals to 2002, right? And then it's equals to the IPv4 address, is the IPv4 address. So the first 48-bit is the prefix length of the IPv6 address, and then is the SLAAD. SLAAD is indicated by the site level aggregator, and it will can defined by the user itself, and finally the interface ID. So the special address is look like this, and when the router receives the IPv6 address, it will get the IPv4 address from the special IPv6 address, and will encapsulate it to the IPv4 header destination address, and also the same as the ISTAP terminal. It just uses the IPv4 address as the interface address, interface ID. So it can also get the IPv4 address from the special IPv6 address. Okay, for these three kind of terminal, they are the automatic terminal. You can find that it's not easy for us to configure, because you need to put the IPv6 network must be as special, must configure the IPv6 network as use the special IPv6 address, right? But as usual, we not use the so special IPv6 address as our IPv6 address. So, so this kind of terminal is not useful for us. So in the real network, we do not use the IPv6 or IPv4 network use. There is no scenario for us to use this, because it's hard for us to configure the IPv6 network. And in the in the real station, we use the 6PE and 6VPE to do as the transition technology. And what is 6PE? As usual, we will for the Bear 1 network, we will establish the MPS or we will establish the MPS or BGP. MPS, IP, VPN. We will establish these two technology to transform the service traffic, right? So the 6PE and the 6VPE is based on these two technologies. Is overlay these two technologies to transform the IPv6 packet. Okay, and what is 6PE? For the 6PE, that means you just use the MPRs to you just establish the IPv4 MPRs tunnel between the PEs, and this PE, and for these two PE, they need to establish the dual stack. That means it not only support for the IPv4 but also support for the IPv6. And this special PE, we will call it the 6PE. And for the 6PE, it will configure the dual stack first, and then for the CE, it just IPv6 network, right? It will send a IPv6 packet to the 6PE just by the IPv6 routing, such as the IGP or SPI version 3, the ISIS or the BGP4 plus sent to the 6PE1. And when the 6PE1 receives this packet, it will use the MP BGP to establish the neighbor relationship between another PE and to add a label to determine there is a packet that is IPv6 packet, and then it will add an outer label. The outer label is sent from the MPLS because you establish MPLS tunnel, just the RSP. So you will use another outer label to send the traffic one hop by one hop. So this is the 6PE, and I just mentioned for the intra-AS 6PE, isolated IPv6 network can connect to the same AS, and PEs in the AS exchange IPv6 route by establishing the MP-IBGP peer. Just I introduced, they just establish the MP-IBGP, and for the MP-BGP, it just assigns the inner label for the IPv6 traffic. And this label is just tell the destination P, the peer P, just to tell it you need to send this packet to the IPv6. That means after you receive this packet, you need to check the IPv6 routing table and send it to the IPv6 network. And however, you just based on the IPv4 MPS RSP tunnel to transform the traffic, right? So you need to add the outer tunnel label to just for the MPS label to transform the packet one hop by one hop. So let's see the whole process. First is the process for the route transition, the route transmission, and when the C1, C2 has a route just like this, it will send the IPv6 route to the 6P2, just a normal IPv6 route. And when the 6P2 receive this route, it will change the next hop of the IPv6 route to itself, and will assign an inner label to the IPv6 route, and the inner label is assigned by the MPBGP. And then the 6P2 sends this labeled IPv6 route just this to the 6P, just to the 6P1, and then when the 6P1 when the 6P1 receives the labeled IPv6 route just like this, it will recurse the route to the terminal and will add the route to the local forwarding table, and then it will change the next hop to itself or the 6P1, and will remove the label from the route and will change it back to a normal V6 route and will send it to the eBGP peer of the CE1. So the CE1 receives the IPv6 route of the 1:1. And then when the CE1 wants to connect to this IPv6 prefix, it will do the data transmission. First, it will send an ordinary IPv6 package to the 6P1, and it's just on IPv6 routing. For this example, we use the eBGP to send to the 6P1, and when the 6P1 receives it, it will look up the destination address of the package and in its forwarding table, and will encapsulate the package within the inner label just sent from the 6P2, the inner label, and then it will add the outer label just sent from the MPS for the RSP. So it will encapsulate, and then it will send the packet one by one by changing the outer label if it has some P devices, by changing the outer label. And when the 6P2 receive it, it will remove the inner and outer label and then it will get the IPv6 package and will check the IPv6 routing table and send it to the destination of CE2 and then to the destination network. So this is the whole process for 6PE. And there is a special label. It's the explicit non-label shared by the 6PE, and the value is 2, because you can find that the MPBGP for each route, the MPBGP will assign an inner label for different routes. That means if you have a lot of routes, that means you will use a lot of inner label, right? So it's a waste of resources. So you can, and this inner label is just tell the destination PE. That means that you need to send this, you need to search the IPv6 routing table to go through the IPv6 normal transmission. So it's only this function for the inner label. So we can use a special just value 2 to assign this value to all of the routes, 6P routes, to indicate the 6P2 that the traffic need to be sent from the IPv6 routing, and you need to check the IPv6 routing table and send to the specific CEs. So this is the function of the explicit non-label. And however, for the 6PE, it's just look like run the same VPN, and the IPv6 service connects through 6PE run in the same VPN and cannot be logically isolated. That means if you want to use the VPN to isolate different services for the 6PE, it cannot achieve this requirement. So as usual, we will use the 6VPE in our Barrier 1 network, because as usual, we will use the VPN to separate the service, right? So for the 6VPE, it just use the just use the BGP MPLS IPv6 VPN just across the V4 MPLS network to establish a BGP MPLS IPv6 VPN to transform the IPv6 traffic. And so for the CE to the 6VPE, it's just the basic IPv6 routing. You can use IGP, also use the eBGP. And for the between the 6VPE, you just use the BGP MPLS IPv6 VPN. And the establishment and the work mechanism of the IPv6 VPN is the same as BGP MPLS IP VPN. Just the IPv4 VPN. So the mechanism we will not introduce here, but the configuration we will introduce it later, because the 6VPE, some scenario has used this technology as the transition technology. And for the 6VPE, and you can find that for the 6P, we use the IPv4 MPLS to transform the V6 traffic, right? And for the BGP, for the VPN V6 traffic, we also use the IPv4 MPLS, right? Because for the IPv6 MPLS, for the MP6 MPLS, there is no enterprise have achieved this technology. This technology is not be used and not be development in our technology development. We only use the IPv6 MPLS, so we can only use MPv4 MPLS to transform our V6 traffics. Also for the V6 VPN. Because there is no achievement for the V6 VPN across from the IPv6 networks, so we can only configure the MPLS IPv6 VPN over the IPv4 network. So this is the 6VPE. Okay, and how to configure the 6VPE? First, you need to create a VPN instance just like this, and you need to assign the ID and assign the RT. Assign the RT just like the MPLS IPv4. And then you need to bind the VPN instance on the specific interface, and you need to configure the IP address again after you have enabled IPv6. And for the between the PEs, you need to establish the MP IBGP relationship to transform the VPN V6 route, just like this. Because you will need to determine the source interface for establishing the neighbor relationship, because you just establish the IBGP neighbor relationship. And then because you just transform the VPN V6 route, right? Or the VPN V6 traffic. So you need to enter the IPv6 family VPN V6 to enable the neighbor. And for the transmission between the CE and the PE, in this slide we just use the example as the static route. And if you want to use some dynamic routes such as BGP and IGP, you can find the detail. In NE's series routers product documents. And here we just introduce the static route. First, for the PEs, because you just create the VPN instance and you bind the VPN instance on the interface, so you need to configure the IPv6 VPN instance route a static route just by this command. It's not a normal IPv6 route static route. And then you need to import because you have established the IBGP enable, right? So you need to import this static route into the IPv6 family VPN instance to import the static route. And for the CE, you just configure the normal IPv6 route static, or use some IGP or BGP, just the IPv6 routing. All of the IPv6 routing technology can be configured. Okay, and then it's an example. For this example, there are 3 AS 100, 200, and 300. And for the CE1 and CE2, they belong to the VPN-A. And in this part, we use the static route to exchange the IPv6 traffic. And from here, it's just a normal IPv4 network, right? So you need to establish a IPv6 VPN tunnel from the v4 network. So first step, you need to configure the v4 and v6 addresses for each interface. And the second, you need to configure the underlay network communication, such as configure the IGP for the AS200. And as usual, in this scenario, it's just like a barrel 1 scenario. We use the ISIs to do the communication between the PEs. So you need to configure the ISIs, and it's not mentioned here. And then you need to enable the MPRs and the LDP to establish the IPv4 MPRs. And these two enable the MPRs and enable the MPRs LDP. And then you need to create the VPN instance just for the VPN instance A, and bind and configure the ID and RT and bind it to the specific interfaces here. And then you need to establish the IBGP enable relationship between the PEs. And you need to enter the VPN-v6 family address to enable the enable. And then you need to, because you use the IBGP to exchange the route from the PEs, and for the PE to the CE, you use the static route. So for the PE, you need to use the IPv6 static route static bind the VPN instance just for the VPN-A, and destinate to the CEs. And then you need to import the static route into the BGP. And for the CE, you can just use the IGP or use BGP4, or use the BGP4 plus, or use the IPv6 route static, a basic IPv6 route static to destination. You can just use the default route, because for the CE, as usual, you don't know the destination, how to connect to the PE. As usual, we will use the default route as the egress. So the same configuration for the PE and for the CE2. So till then, you have configured the 6VPE, and let's do some verify some information. First, you can display the BGP VPN-v6 peer. You'll find you have established the neighbor relationship between the P2. And then for the CE1, you can use the source address, just the CE's loopback 1 address, and use this address as the source to ping to the destination just for the CE2's loopback address, and then you find you successfully to communicate with the destination. So the configuration is correct. Okay. The first three parts is about the tunnel of IPv6 over IPv4, and this page is for the IPv4 over IPv6, and this tunnel also do not being established in our real network, so we just introduce it simply. In the late stage of the transition, we will use this tunnel because most of the network has been IPv6, but there have some existing IPv4 isolation network. You need to connect them together, so you can use the v4 or v6 tunnel. So for the R1, for the two border device, they also need to establish the dual stack. Then they receive the v4 package and encapsulate the v6 header to it, and then change to the v6 package and send this packet to the end border just for the R2, and R2 will decapsulate the v6 header and will check the IPv4 routing table to send this packet to the destination. And as usual, the v4 over v6 tunnel need to be configured manually. Okay. And the final two technology is about the network address translation technology. And the first one is the NAT64, and the NAT64 is the translation between v4 and v6 addresses. And there the scenario we use the NAT64 is for the for example, the v6 users want to connect to the v4 service, or the internet v6 users v4 users want to connect to the v6 service. So there is two scenarios for the NAT64 or NAT64. And how does the NAT64 achieve this requirement? Is based on the special prefix. We call it NAT64 prefix. For this prefix, it has two kind of. The first is well-known prefix. It look like this, and another is the predefined prefix. That means you need to define it manually in advance. And for the prefix, it has a fixed length for the 32, for the 40, for the 48, and for the 96. And because it has the special prefix, so for the NAT64 gateway, it's just the translator. It just recognizes the prefix. That means when I receive the for example, when I receive an IPv6 package and I find the destination IP address, IPv6 address with the special prefix of the NAT64 prefix address, I will change it to the v4 address. So it will become a v4 packet. So it will send to the destination of the v4 user. Okay, so this is for the NAT64 gateway, how to recognize the when it transfer or when it translate the IP address, just when it recognize the special prefix. Okay, so this is the format for the prefix that you want to determine it by yourself. So the prefix length is for the 32 to the 96, and next part is for the v4 address. V4, when you use the 32 length prefix, and then you will and then it was the IPv4 address. So when the NAT64 gateway recognizes the IPv6 address like this, it will just get the IPv4 address from this IPv6 address because it contains this IPv4 address in it. And there is two scenarios. The first is dynamic net64 scenario. Dynamic one. Dynamic means when the net64 gateway receives the packet, it will dynamically transform the IPv6 address to the IPv4 address, or transform the IPv4 address to the IPv6 address. So let's introduce the whole process for you. The first, when this is the topology. There is the IPv6 user with the IPv6 IP address, and there is the IPv4 server, and the server's web is the example.huawei.com, and with the IP address of 1.1.1.1. So when the IPv6 user wants to connect to this server, it will send a DNS4A request to the DNS34. This request is contained the example.huawei.com, and it wants to receive the IPv6 address of the destination address of the server, right? So it will send a 4A request to the DNS64. And the 4A record is maps a host name or domain name to an IPv6 address, and another is the A record. The A record maps the domain name to an IPv4 address. This is for IPv6. This is for IPv4. So when the DNS64 receives the 4A request, it will check if there any IP address mapped to this domain name, and then it will not find, because this is IPv4, right? So it will go through the A request, and then it will check if there any IPv4 address mapped to this domain name. So it will find the IPv4 address is 1.1.1.1. And this DNS is also a special DNS. You need to configure it in advance. So it will recognize, oh, this is a net64 IPv4 address. So it will use the well-known. Can you find it? It will use the well-known prefix to configure the IPv4 address and change it to the net64 IPv6 address, just like this. So it will reply the FOIA request package with the reply just with this IPv6 address. So when the IPv6 user receives this reply, it will contain its IPv6 packet, and the packet with the source address is the user's IPv6 address, and the destination address is just the service mapped net64 IPv6 address, right? Can you find it? So when the special net64 translator receives it, it will just transform the destination address to the net64 IPv4 address. Just find the destination IP address from the destination IPv6 address, just the 1.1.1.1, right? And how about the source address? It is a dynamic translation, so it will just use the address pool. It will find the IPv4 address pool to find an IPv4 address to transform from the source address. So, and then it will just get an IPv4 packet, right? And after it gets the packet, it will also create a session table for this firewall. The session table is the source IPv4 address to the source IPv6 address, and the destination IPv4 address to the destination IPv6 address, just like this. So then the request will be sent to the v4 server. So when the v4 server receive it, it will reply, and the replies with the source address is its own IPv4 address, and the destination address is the mapped IPv4 address. So when the firewall will receive this IPv4 address, it will just check the session table and change it to the IPv6 packet and send back to the user. So this is the whole process for the dynamic NAT64 translation. Okay. Another example is for the static NAT64. This is the scenario. You can find that there is IPv6 server. It has a IPv6 server in our internet, and it with the domain is example.huawei.com, and IPv6 address is like this. And then for the internet, it will have a mapped IPv4 address is 2.1.1.10, and will advertise this IPv4 address on the whole internet, right? On the whole internet. So when the IPv4 internet user want to connect to the server, it will just send a request to a DNS, and the DNS will reply the destination IPv4 address just like this. This has been advertisement to the whole internet, because it's a server, and so it will just encapsulate it IPv4 packet just like this. And when the NAT64 receive this packet, it will just change the destination address to the mapping one to the server IP address just like this, because it's just our server. And for the source IP address, it just use the NAT64 prefix to change it from the IPv4 to the IPv6, and the prefix has been pre-configured on the firewall, so it will just use this prefix to combination with the IPv4 address. So you create a new IPv6 new IPv6 address. So you get the IPv6 package to the destination, and then it also will create the session table, map between the v4 and v6 address. And when the server receives the packet, it will reply. So for the firewall, it will based on the session table to change the v6 to the v4 address. So this is the whole process for the static NAT64. And in the for the development of a data center IPv6 changing, in the early time we used the NAT64 technology to provide the several v6 applications. It's a useful technology in some of the data center scenario. Okay, and how to configure the NAT64? First, you need to configure. First, you need to enable this function globally, or you can enable it on interface. And you need to configure. You need to pre-configure the prefix, right? Because you need to tell the firewall what is the specific prefix you can use, and then you can display it. And there are two kinds of this NAT, right? The first is dynamic. So for the dynamic one, you need to assign the address group for the source IPv6 change to the source IPv4, and then you need to configure the NAT policy, because this is configuration for the high-sec serials USG firewalls. So for the firewalls, you need to configure the NAT policy for the rule and change the NAT type to the NAT64. And for the static NAT, you need to configure the static NAT from just to configure the map between the v6 to the v4 address. Also, you can configure the mapping from the SMP or the mapping from TCP or UDP, just from the v6 to the v4 with the port number. Okay, there's example for the dynamic NAT64. This is the scenario for the internet for the for the internet there is IPv6 user, and for the internet you just provide an IPv4 server. So if the user want to connect to the v4 server, you need to configure the IP address security and other firewall configuration first, and then you need to configure the security policy for the firewall, and then you need to enable the net 64 function. And in this scenario, we use the interface to enable the this function. So in this interface, you need to enable the net 64, and then you need to configure what is prefix for the net 64, and this is the prefix you used. And then you need to, because this is dynamic one, so you need to assign the address pool for the firewall to transform the source IPv6 address to the destination IPv4 address, or to the source IPv4 address, and then configure the net policy for the net 64. Change the net type, configure the source and destination zone, and configure the source address. And the action is net. And also you need to configure the PCs. You need to configure its IPv6 address and configure its IPv6 route, and you need to configure the IPv4 servers. The server also need to configure the DNS to do as the DNS64 function, and then you will find the v6 user can connect to the v4 server. Okay, and the final technology is the IVI, and the IVI is just a stateless address translation technology, and it just reserve a part of IPv4 address segment, and we call this segment as the IVI4 address, and this IVI4 address is mapped to a group of IPv6 address segment, and this segment we will call it IVI6 address. And for these two special address, for the IVI4 address, we can use it to connect to the IPv4 internet. And for the IVI6 address, we can use it to connect to the global IPv6 address. So these two part address are reserved. And what is the format for the IVI6? It has the IVI prefix. The first 32 bit is IVI prefix, and this prefix has been reserved by the carrier, and then is the 8-bit for FF, and then is the IPv4 address, and this IPv4 address is just the IVI4 address, and the final part is just all zeros. So this is the special format for the IVI6, and it also can be changed from the v4 to the v6, or from the v6 to the v4. So let's see an example of IPv6 host to connect to a global IPv4 server. In this scenario, the stateless IPv6 address auto configuration can't be used due to the special IPv6 address format. Therefore, the IPv6 host obtains the IPv6 address, default gateway address, and DNS server address through the static configuration of DHCP version 6 options. Because it will use the special IVI address, right? So you need to configure it by yourself, or use the DHCP. It cannot use the SLAC. And then it will send the IPv6 packet to the IVI gateway. And when the IVI gateway receives this packet, because the source and destination address, both of them are IVI6 address, so the gateway will directly change it to the IPv4 IP address for the source and the destination address. So it will get the IPv4 packet to the destination. So you can see the limitation. Then for the limitation is that for the host and for the servers, all of them need to be configured the IP address just based on the IPv6 or IPv4 address. It's not flexible for us to configure our network. So in Huawei's opinion, we think it's not easy for us to do the real network deployment. So we not use it to do as our solution to deploying the IPv6 network. So if you want to use the translation, in our opinion, we suggest you use the Net64 technology to do as a translation technology. Okay. Okay, this is the whole information about the IPv6 transition technology. And then let's see some quiz. The first, which of the following technologies can be used to carry IPv6 service traffic on IPv4 That means you need a course from the v4 network to transform the v6 traffic. That means you need based on the v6 over v4 tunnel. So for this tunnel, there is a manual tunnel or the GIE tunnel, or the 6P or 6VP. For the 6P, you just based on the MPLS IPv4, and for the 6VP, you just establish the VPN, the IPv6, the VPN v6 over the IPv4 MPLS, right? And for the Net64, it's not a tunnel technology. It's just a transfer. It's just a translation technology. So it cannot achieve this requirement. So the answer is A. Sorry, the answer is A, B, D. Okay. Okay, this is all information about this slide, and this slide is not very important because in this time most of the in the Barry 1 scenario, they will just use the SR version 6 to support the IPv6 traffic, and for the campus and for the data center, we use the VXLAN. We use the VXLAN to support for the IPv6 services, and these two parts we will introduce it in the later day, maybe in the next week. And however, we need to know something about the transition technology because this technology has been developed to use during the long time from the transition from the v4 to the v6, and in some scenario we will use 6VPE for the Barry 1 network, and for the campus network we maybe use the dual stack, and for the data center sometimes we'll use the Net 64. So only these three kinds of technologies has been used, and for other transition technologies, in my thought, there is no scenario for them to use, but we need to know something about them. So this is a slide's key point. Okay, so this whole information about today's course. If you have any questions, you can tell me in our chat group. If no, I think today's course is finished, and let me check tomorrow information. Tomorrow. Tomorrow we will learn something about the final part about the routing and switching, its queues and some operation and maintainers about our network. So after tomorrow, the first part about the routing and switching is finished, and next week we will introduce the campus network scenario and the WAN interconnection scenario. Okay. So if you have no question, today's training is finished. Thank you all. Goodbye. See you tomorrow.
Thank you.
Thank you for your time. See you tomorrow.
Okay, thank you all.